Example 1, maximizing area. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Okay, so let's go back to the steps in solving and optimization problems. We want to understand the problem. So we want to ask ourselves, what is the unknown? What are we looking for? What are the given quantities? Well, we know that the given quantity is that a farmer has 2,400 feet of fencing, right? And we know that it borders a straight river, but does not need a fence along the river. Okay, so that's what it's telling us, and it's asking us to find the dimensions of the field that was the largest area. Okay, so in part 2, we want to draw a diagram because that's going to give us sort of an idea of what we're looking for. Okay, so let's go ahead and draw a diagram. All right, so the first thing is I'm going to draw a diagram, and so we have a rectangular field, and this rectangular field, it borders a river. Okay, so if it borders a river, okay, so there's the river, and there's no fencing that needs along the river. Okay, so what do we know about this? Well, again, this is the river, and there's one length, and then we have two widths. Okay, and so now we want to write out what is the information that we have. Well, we know that when we're talking about area, we're talking about the area of a rectangle. And recall that the area of a rectangle, the formula for the area of a rectangle is equal to the length times the width. Okay. And so what do we know? Well, we also know that we're given that the farmer has 2,400 feet of fencing and wants to fence it off of a rectangular field. So that means that when we talk about the perimeter, well, that's equal to 2 times the length plus 2 times the width. But since this is what our perimeter is, we notice that we only have one length. So we don't have 2 lengths, we only have 1. So that means we're only going to use 1 length. Okay, so what is the perimeter of our problem? Well, the perimeter is 2,400. It's going to equal the length plus 2 times the width. Okay, so what we want to do is we want to be able to solve for L and then plug it back into number 2 for the area of the rectangle. So if we solve for L, that means that we would subtract 2W, so that means that L would then equal 2,400 minus 2W. Okay, so now that we found this length, now we're going to plug it into the formula here. So for step 4, we have the area, which is equal to the length, which we now know is 2,400 minus 2W times W. Okay, so now what we want to do is we're going to go ahead and then distribute. So we're going to get 2,400 W minus 2W squared. Okay, so now that we know the area of this, okay, we can rewrite this so that we have, and we can put this in descending order, so we have negative 2W squared plus 2,400 W. Okay, so now that we have found the area, okay, now the area the formula for the area, what we want to do is now we want to find the derivative of this formula. So what we want to do is we want to find the derivative of a, which is equal to negative 2w squared plus 2400w. So to find a prime, we get negative 4w plus 2400. Okay, and now what we're going to do is we're going to set this first derivative equal to 0 and solve for w. So negative 4w plus 2400, and that's going to equal 0. So if we solve for w, and divide by negative 4, well, w is going to equal 600. So we know that the width is going to be 600. Okay. And so how do we find the length? Well, we know that we had the formula for L because L is equal to 2400 minus 2W. So that's 2400 minus 2 times 600. And so therefore L is going to equal 1200. And so therefore we can say that the dimensions, which is what we're looking for, is going to be the width, which is 600 feet, by the length, which is 1200 feet. Okay. All right, now there's one more thing we want to do is we want to talk about those critical numbers. So let's take a look at part 8 here. Okay, so remember that the maximum value must occur either at this critical number, which we found here at 600, because that was the derivative value that we got when we set it equal to 0, or at an endpoint of the interval. And so the interval for the width goes between 0 and 1200. So the endpoints are going to be 0 and 1200, and then we have a critical number of 600. And we're going to evaluate all three of these values into the function for a. So we want to find, okay, what happens when we get a of 0? Okay, we plug that into negative 2 times 0 squared plus 2400 times 0. Well, that gives us a value of 0. So therefore, we have a ordered pair at 0, 0 so far. Okay, and then we want to find a of 600. Okay, so if we plug in 600 into our function, we have negative 2 times 600 squared plus 2400 times 600. Well, that gives us a value of 720,000. And so therefore, we have an ordered pair of 600 and 720,000. Okay, and then if we plug in the value of 1200, negative 2 times 1200 squared plus 1200, or 2400 times 1200, well, that gives us 0. So therefore, we have an ordered pair of 1200 and then 0. Okay, so what does that tell us? Well, it tells us a couple things here. Okay, it tells us that 0, 0 and 1200, 0 represent our minimum values. Okay, and then the maximum value must occur at this critical number. Well, the critical number is 600. So we can see that this is going to represent the maximum. Because again, this represents our critical number.